Once again, hello dear students. I'm really glad to see you in our second lesson in Python course. So I think I want to start with some review of your homework, some essential things. So let me start my desktop. Okay. So I have read some answers from you and want to share some comments about your submissions. Okay. I write down your submissions for the first task because it's very simple. And let's start to review some code. It is without your surnames and not personalized. But I think it's very important to understand what's going on and what can be run. First of all, let's talk about my template for the code. What does it mean when we have such expression as def main, and I have write your code here, and after that I have main. So you asked me what is this and is it necessary or not? Of course, for the automated system, it's not necessary because what automated system do, maybe it be more clear if I draw it. So where is the annotation? Annotation. Actually, I don't understand. In this version of Zoom, I have no annotation. What? Okay, let's go to another screen. So how automated system works? It has output and input streams like your console in the command line interface. And the system gives you an input inside the console. It can be, for example, for the first task, 2 numbers, 1 and 2, divided by the symbol of the new line. And your program here, your code, gives an output into the same console. For the first task, it must be number 3. And the system check only your output. So in the inner console of the automated system, it must be like this: 1, 2, and after that, your program print 3. For each test, it read the console and wants to see only this in the output stream. So of course you can write your code without such construction, but what does it mean? It's not an abstraction. So programmers decide to use such construction as an entry point into your program. This is more about architectural conditions. And so when we write a code and we want some other people to read it, or we want to know where this program starts, we want to explicitly choose the entry point in the program. So main function is a special function that is executed at the first place in every program you will see in enterprise programming or in the huge projects. So you must know that this is the first function that will be executed, because in huge program, in huge code base, you have a lot of functions, a lot of classes, and to trace it down, you must know when to start. And in Python, we have another thing, because in Python, we can use our code files like libraries, not the programs. We can import different files into the program, but also we can run each file like a program. And for these purposes, we use the construction like this. If name equal main, just execute main function. Don't be afraid of these statements. It's just construction to understand where is the entry point in our program. So main is always the major function in all code base, and we start with main. And of course, in your test cases, you can get rid of it and just use a pure code. So in first code snippet here, we have a mistake with indentation. So I told you that each code block inside the function, inside the conditional statement, inside the cycles, we have an indent for the body of the function, cycle, or condition. So here we must have 4 spaces or 1 tab if you use tabs. Okay, next example. So here, this is a mistake that I described in the automated system description. So what does it mean when we have an argument inside the input function? So let's try to see it. So your input function wants an input from you in this example, it wants input from the user, but in static example, it wants input from the automated system. And it's just read it from the input string. But if we have an string argument inside this, it prints it inside the console before input. So it prints hello and wants you to input some text. Okay. So if we have arguments inside input function, it will explicitly write it down into the console. And of course, it will be the wrong answer for the automated system because it wants you to output only a number. Okay, so here we want to have clear functions for input. And of course, here we have some formatting of the output, but the automated system wants only one number. Okay, This is an example of code without main function, but what we have here, we have a space between function input, and its arguments. In Python, we use such syntaxes that we have function and arguments without any spaces. It will be a syntax mistake, and interpreter will raise an error. So, for example, let's define function foo that do nothing. The word pass is the special word for the functions to do nothing. Oh. So now I have function foo. We can check it. So foo is the function, but if I want to run it with the space between arguments and the function name, it will do nothing. Why is it so? It looks like that this is same as run foo without any brackets, and it's just return the object. So the function is object 2, and this statement will return at first object foo, and after that empty tuple. No, it's not a tuple. What is this without anything? It's just brackets. Okay, so using functions without a space between arguments and function name is a mistake. It will not do anything. So here we must delete spaces. What we have here, this is another problem with indentation. Okay, we talked about it. Here is a right code. It will return the right answer, but architecturally we have some mistakes. So why we need so many names of variables here? Maybe it's better to use the nested function. So use int function and the result of the input function inside the int arguments. And we can get rid of this. And do not forget to refactor your variables. So it will be A, it will be B. Okay, this is a very interesting piece of code. We still not talk about lists, but it's a legit code. And what does it mean? It means that list consists of two names A and B is equal to the list consists of two results of our input. But very interesting. We can do it without list. And I think this is very useful. So still wants to have annotation in my Zoom. Okay, let's write it here. So this is about sequences. What to drag? In Python, we can define sequences like this. So 1, 2, 3. And we can make an multiple assignment. So this is an assignment statement, and we can assign 3 variables and in the one time. And the result of this assignment will be that A will be linked with 1, B with 2, C with 3. It's absolutely legit for the Python syntax. And we will understand how it works later when we will talk about tuples. And the very interesting moment here is the switching of the variables. If you have some experience in other languages to change variables between each other. So for example, A is equal to 2 and B is equal to 3, and we want A to be 3 and B to be 2, we must have a temporary variable. So we have temp equal A equal B equal temp, and after that somewhere we must delete temp. But in Python we can do such things. AB is equal to BA, and that's all. This is a swapping of the values for the variables. And how it works, we will talk about it a bit later. So here we can not use brackets for list. It's not necessary. It will work, but it's not necessary. A more laconic way is just to use this type of assignment. So it's called multiple assignment. And the last thing, what we have here. Oh, okay, this is just a legit way to assign variables. Okay, most of you was successful with the first module, and I think that with all questions you can ask in chat or me in private messages, but it's preferable to use chat, of course. Okay, I think that's all for the review of the homework. Let's start with our today lecture. So first of all, I think you is familiar yet with the concept of the set theory. I know that you have classes with discrete math about set theory, and let's try to talk about conditional statement using the set theory. So we know that conditional statement is like this. If condition 1 do something, else do something else. And of course, we can have a lot of conditions here. But how we can think about this? Assume that we have a universal set of all outcomes. I do not know your annotation for the universal set, but usually in mathematics we have omega for this. So this is a set that consists of all possible outcomes here for this condition. For example, we have a real numbers line. What kind of numbers we can have here? We can have 0, numbers that are positive, and numbers that are negative. Assume that we have such condition. if A is equal to 0, print 0. Elif, if you remember that elif is the another condition in the same conditional statement. Elif A more than 0, print plus, and else print minus. So how it will look like? We have our omega set that consists of all numbers for the A. Let's assume that A has integer type. How many elements this set contains? Very simple question. So assume that you have a 32 bits machine and your int type is 32 bits. So what does it mean 32 bits? That each number will be represented like sequence of zeros and ones with length 32. And to understand how many such sequences we have, we can use combinatorics. If you're not familiar yet, you will know it in discrete math. So for the sequence of 32 different digits, it will be 2 in the power of 32 different numbers. So the answer is 4 billions, almost 300 millions elements in this set, in set omega. What we do when we have conditional statements, we dissect our omega set. So assume that we have 0 here, like an element. One element of this omega set is just a 0. We have all positive elements here, all negatives elements here. First condition and first conditional statement will cover the one element from the omega set. Second condition will cover all positive elements from here. And the last else condition will cover all other outcomes. So it will be our negative elements. That's not all, of course. We can use logical operators here. So once again, I want to erase this. What kind of logical operators we have? The same logical operators like in set theory. We have AND operator, we have OR operator, and we have NOT operator. So what does it mean when we use logical operators? First of all, logical operators works with Boolean types. Let's go to the code. For example, true and true will be true. True and false will be false. Okay, I assume that you know how logical operators works in logic and in set theory. So we have, if you have questions about logical functions in logic, please ask the question. Okay, so in the Python language, logical operators work with the Boolean type. So true and false are two objects of the bool type. But we can use another types in statement with logical operators. For example, we can use 1 and true. It will give us true. We can use 56.1 and true, and it will give us true. This is because we change our type inside the logical operator. And for the numbers, for integers and floating points, the rule is that 0 becomes false and 1 becomes true. So we can use, for example, conditional operator equal. So 1 is true, that is true. 0 is true, not. This is not true. Floating 0 is not true. What else we have? If you remember the difference between is operator and equal operator, we can try to do this. 1 is not true because we can't use is with the literal. So we can create a variable 1 and ask A is true or not. No, it is not true. It is a 1. But if we ask is A equal to true, yes, this is true. Okay, so for the numbers, it is clear, I think. So we have zeros that are false, and we have other numbers that are not false. So even if we have negative numbers, they are true too. Oh, why so? So why minus 12 is not true? Yes. No. Okay. So what we have here, why equal operator returns false here. Minus 12 is not equal to true. Let's go to the internet and try to understand how equal operator works. Okay, I will try to find the answer for this question because I have no time for this for now. But we talked about conditional statements, and here we can legibly use numbers like a condition, and it will work. And if we use here zeros of all kind, it will return us that it's false. The same thing is for string objects. So if we have such string, like any symbols here, okay, I must Google for the equal operator, but if we use a conditional statement, we have the same result. So if we have not empty string, we will have true. Other case, if we have empty string, it will return us false. So the rule is for numbers, 0 is false, other numbers are true. For the strings, the empty string that is just quotes without any content, this is a false. So if we have some string that has len 0, it will return us false in the conditional statements. Let's go back to the conditional operators. So here we can use not only bool types, but another types for our condition. For example, we can use numbers, we can use strings, and of course the bool types. For example, 1 is less than 5. This is a statement that will return us true. So here we have a huge statement that consists of 3 parts. First part is the integer number, second part is the not empty string, and the last part is the statement that return true condition, and the result will be true. So it works really like in set theory when we use conditional operators and or not. For example, for this set, we can use condition like if a is equal to 0 or a less than 0. And what we will have on our graphical representation This condition means that we use all outcomes from here and from the negative subset. What is the main rule how to use condition? Please try to cover all possible outcomes. So if you understand how your code works, you must to think about all possible outcomes and non-possible values of the variables inside the condition. To avoid the mistakes, you must think about all possible outcomes. To not miss the event when you have some outcome that is not described in your conditional statement. But of course, if you have else section, all that outcomes will be here. But if you didn't think about it before, you will miss this condition and it will be a mistake, but not a syntax mistake, but mistake in runtime. So it will be a logical mistake because all the statement operators and all the conditional operators is all about logic, how your workflow must be controlled inside your program. So please pay a lot of attention into the conditions and what possible outcome you will have in your variables inside conditions. Okay, I think that we can go for the next theme, and it will be about iterable objects. So what is this? I think this is an essential to understanding how Python containers and other things works, how we can work with for cycles, for example, how we can work with slices and numeration of some sequences inside Python. It's an iterable objects. I think I have some good abstraction for the iterable object. I know that almost all of you are biologists now, have some relative background. Let's think about iterable objects like a polymer, for example, DNA molecule or other things. We have some kind of sequence of monomers here. And if we have this type of object, we can do the specific things. First of all, we can get each of the monomers one by one. You can imagine some machine with the lever and all this polymer stuff here. And each time we pull the lever, we have the next and next and next element from this sequence. And another thing that we will know about iterable objects, then they have indexing. We can understand which number each element has. And using this indexing, we can slice this object and can get only the part of it with different conditions, whichever indexes we want for us. So I think the first iterable object that we want to consider is the string. I think I want to use the text editor for this. So okay, let's start. Assume that we have some string like this. And we want to somehow iterate each letter from this string. So another thing that I want to show you is how to understand that some object is iterable. It's very simple. In Python, we have a special function called dir. Dir is a function that returns every method that each object has. So we have some string. So S is just a string of the symbols, and we use dir function. It returns us all the methods that this string has. And look here, here we have iter a method. And this means that S object is iterable, and we can use it, first of all, to iterate our it. And of course, we can slice. So how it works? First of all, let's try to meet for loop. Here we can use a really cool syntax sugar. We can use like just English language to iterate our string. So for here I write that for each character in string S, please print this character. And let's try to run it. Python. And it returns us all the symbols one by one for this string. We can create more complex condition, for example. What I write here, I have a condition in the conditional statement if character in something. So the new things for you is this construction. For now, you can think about it just like a sequence of different objects. This is a sequence of 3 different characters, E, L, and S. In operator means that this character is in this sequence. So how it works? For loop will iterate our string. First of all, it will return a character capital H. And here it will ask, is capital H in this list, in this sequence of the characters? No, it will not do anything. After that, the for cycle will return E character. It asks, is character here? Yes, it is here. And it will print E character. So let's try it. And okay, it returns us only characters that are in this sequence. The thing is that this polymer abstraction in Python, iterable object, can be not finite, for example. So it can be infinite sequence, or it can be empty. Think about iterable object like object that have some property. This property means that we can go through this object by element, one by one. And another thing, we can use slices. How slices works in the first glance. For example, here, assume that we want the second word from the string. We can count the indexes for the second word character. So H is the 0 symbol. This is the first symbol, L second, L third, O fourth, space fifth, and this is the 6th symbol. 6, 7, 8, 9. So to return dear, we must use slicing. So I want to print it. For slicing, we use annotation with square brackets. And in square brackets, we first write the start index, and after that we must write end index -1. So if we want from 6 to 7, 8, 9, we must write here a 10. Oh. We have notation with a semicolon. Okay, we have a deer. So once again, iterable object has property of iterate our itself and to give you a slice of itself. Let's try to look at another iterable objects. So I showed you such things. E, L, and I don't know, S in the curved brackets. So these special objects are called tuples. So we can write type of this, and it returns us class tuple. How to understand what is tuple? Let's return to our data model. If you remember, we have names and objects. If we write a equal 1, we have integer 1 and name a and link between them. After that, if we have name b and integer 2, we have object 2, name b and link between them. But if we create a tuple can be created using curved brackets and comma. So if we create such things as a, comma b, here we have space by the pip8, and call it, for example, t. We create t name and a special object that have 2 places, and these 2 places will contain links to the previous objects. So from here we will link to the 1, and from here we will link to the 2, and this is a tuple. You can think about it like a sequence of some objects. So it can be 1, a, true, none. This is our polymer. But in this polymer, all monomers are the different types. So this is 1, this is integer, this is string, this is bool, and this is a special none type. But it's still a legit iterable object, and we can iterate over it, and we can get any value from the tuple by its index. So let's go to the code. Let's create some test tuple, and it will be equal to 1, 1.2, like a float number, true, some text, and none object. Let's at first just iterate our it using for cycle. So for element, like in English, for element in test tuple. Please print each element. And it returns us 1, 1.2, true, some text, and none object. So this is not an object, this is just an output of the print function. So output of the none is none. Okay, but we can use slicing, for example. The first and very simple example of slicing is getting element by index. For example, we want to use zero element of the tuple. It returns us true. Please give us the first element of tuple. It returns us 1.2. And now we want to use elements from the first to third. So we must create index 0, 1, 2, but here we have the end plus 1, so from 0 to 3. And it returns us the sequence of elements. We can do it even with negative indexing. So if it is the 0 element, this is the -1 element, and this is -2 element. So we go in the from right to left direction with 0 indexes. So if we want to use -1 element of the tuple, it returns us the none. If we want from -2 to -1, so here it will be some text because it must be end plus 1 here. But to use it to the end, we can use the empty space here. So I understand that looking for the slicing rules at the lecture is not the same as practice by itself, by yourself. And of course, I will send you a link where you can read about slicing rules. For now, I just want you to understand how we can work with the iterable objects. Once again, iterating over them and using indexes, because each element inside iterable object has its own index in the sequence. Okay, we have talked about tuples, but there are a lot of, not a lot of, but there are another containers in the Python languages. So in this representation, we have tuple here, and the next thing I want to talk about is the set object. What is the set? It's really the same thing as a tuple in the first glance. So assume we have such tuple: letter A, letter B, letter C, letter C, and we want that in our sequence all elements will be presented only one time, and we do not interested in the order of these elements. So we just want to know, for example, in word hello, how many different unique symbols we have. How to do it? We can use a set object. So how it works? Once again, assume we have such tuple A, B, C, C. Let's call it T. And now we want to show only unique elements here. We can create a set from it. using function set, for example. And it will return us only unique elements here. Another way to create a set object is to use curly brackets. Okay, what we have here, we create set from the T, and T is a tuple. And with this notation, it create a set that contain only one element, a tuple, and it's unique. So I think this is time to look at another conception. So how to, this is a star conception of unpacking the iterable objects. So assume we have tuple with A, B, and C. And we want to use in set. So we want to create a set object that will contain A, B, and C. But if we use notation, so this is a T equal ABC. If we use this notation, it will create a set that will contain only one link to the tuple object that inside have links to the character objects. But we want this variant. And to create it, we can use asterisk notation. So it unpacked the iterable object. How it looks like. So we have our tuple, and when we use unpack, for example, A, B, C, D is equal to T. Okay, A. So we just get rid of the tuple objects and give just elements of the tuple inside the set. But it works only with this notation. There are another examples of using list unpackage, and I think I will talk about it later, because now we are considering containers in the whole. So I just want you to describe all major containers of Python today. And I think we can talk about unpacking of the containers on the next lesson. So about set. There are, once again, two types of creation, two methods to create set. Set function with argument of some iterable object, and curled brackets with asterisk and iterable object. But let's do the task with the unique characters in the some word. So I will close this and create new. Assume once again that we have string equal Hello, how are you? And we want to know what letters we have in these strings that are unique. We can create a set of the characters from the iterable string s. And after that, we can print char set, and we can print how many elements we have. For example, we can create some formatting here. So unique chars and how many unique chars. How we call it? Unique chars. So we have our output. I don't understand why we have this string, because this is our print function output. And none. Why we have none? Okay, let's create traditional function main to avoid some mistakes. Why we have this output? Okay. First of all, here I do not want print, I want length of the char set. Okay. Okay, that was a mistake. So here we have unique characters from the string hello, how are you? And look here, they are not in the order of the original string. They are in some order, and you must consider it when you use set, because set is not about order. Set is about uniqueness. So it's return all elements, but not in the original order. And this is a length, how many unique elements, how many unique characters we have in our original string. Okay, let's go next. And what we can do with the sets. As you remember from your last lection of discrete math, sets has operations, so we can unite sets, we can intersect sets, and we can negate sets. So set operations in Python. And here we are, we have the same operations like in set theory in discrete math. So how we can interact with them? So assume we have string 1 that is, for example, hello, and string 2 that is, I don't know, world. We create char set 1 for the first string. We create char set 2 for the second string. And now we want to use set operations to, for example, understand what these strings have, what characters both of these strings have. So, for example, S1 and S2 has L, and of course, letter O. So how to do it? We can use intersection method. Like described here, we have union, intersection, and difference method for the sets in Python. So let's use intersection. And the arguments are our sets. What's wrong? Intersection. Okay, this intersection method can be called from the set. So if we remember the function dir that show us all methods that object of the set has, we can find intersection here. To call this method for the object, we can use dot intersection. So dot means that we call the method of this object. What is the method? The method is the function that is included in the object. So this is a set object function, and it is inside this object. And using dot, we execute this. And inside argument, we can use another set. So char set 1 intersect with char set 2. Okay, and it returns us 2 letters that are both in the string 1 and the string 2. If we want to know all unique letters from both strings, we can use union. And this is all characters that are in both strings. And of course, we can use difference, how it calls, it's here, difference between sets. So in set theory, I think you have such notation that A difference with B. And it means that we have A set, we have B set, and A difference with B would be that part. So all elements are that belongs to A, but A not belongs to B. And all of them are here. The same thing we can do in Python. So char set 1 difference with char set 2. It means that please show us all characters from word hello that are not in the world in the word world. Okay, and these unique characters are E and capital H. So I think for now it's all about sets, and I think you can try it in your homework, because the practice is the best method to understand what's going on. Okay, and I think that I have time for the last one, but not the least container. Actually, it's funny, but it's called list. What is the list? List is absolutely the same thing as the tuple. It's just a sequence of some kind of elements that is, of course, iterable object. We can iterate it one by one. We can use indexes to get objects from the list. But the main difference of the list that it is a mutable object. What does it mean? If you create a tuple T, for example, 1, 2, and letter A, you create it forever. So only thing that you can change here, you can delete it. So you can get rid of full tuple. You can't change elements inside tuple. It will be forever object 1, object 2, and object letter A. But if you create a list, and to create a list, you can use square brackets. You can change elements inside. You can say, so let's call it list. It's better, it's really bad to use word list to create some list, because there are two notations of list creation. First notation is like in set, list, and some elements here. So list 1, 2, 3 is the same as square brackets and 1, 2, 3 inside. Okay, one moment. So the same thing is for another container. So set of 1, 2, 3. Look, here is a tuple, not just 1, 2, 3. Is the same as such brackets 1, 2, and 3. And for tuple, we can use word tuple 1, 2, 3, and this is the same as this type of brackets. 1, 2, 3. And you can see why we called such things containers, because they contain some elements, but they are different types of containers. And these two are pretty much the same, with the difference that this is unmutable. These values here are frozen. And this is mutable object. We can change each element. How to do it? So I think I have only 8 minutes. So let's quickly create some test list. For example, 1, 2, and 3. And try to get 0 element. It will be 1. But now let's change it. We explicitly create an assignment statement and tell, please, 0 element. For now, you will be A. And if we print our test list, the 0 element will be changed. But if we have test tuple, one, 2, and 3, and try, first of all, try to get a 0 element. Yes, we can get it, but if we try to assign it to anything, for example, B, it will return us error. So the legit question here is why we need 2 types of containers, such as tuple and list, if they are the same but with additional functionality in list. Why we can't have only list? First of all, it's because of the inner implementation of this object. The tuple object is much more simpler than the list, and it eat a bit less memory if you create it. And of course, it is needed when you want that your object have the property of immutability. So in some cases, you want that nothing can change your object. And of course, it's preferable to use tuples inside. So for example, some constants or some information that must not be changed during the runtime. So, okay, tuple and list are pretty much the same, but in tuple, we cannot change the elements inside, and in list, we can do it. The thing is that this set object is mutable too. We have functions that can add elements inside and through elements outside. So we can change elements inside the set. It's a mutable object. We can add elements to the list. We can get rid of elements from the list, but we cannot change the elements inside tuple. So I think that's all for today, but I will write much more and will send you links to the documentation, I think, where you can find the full information about every abstractions that I told about today. So please, I know that last time I forgot about your break. I have 2 minutes, I think. You can ask your questions if you have.
Yes, I want to ask one question. Just to clarify, so when I create a tuple and, for example, I have one variable a which equals to 2, and I create a tuple which includes this variable, tuple will only memorize the object 2. But when I change the variable a to some other number, tuple will not change.
Very interesting question and very good. If you understand the model of the data representation, you can answer it. So look this. We have a equal 2. We have tuple that has a inside. And now we change a.
Okay, thank you.
So the thing is, have I here some model? Okay, I will draw another. Name object. So a equal to. We create int object 2. We create a name a. We have a link. We create tuple that contains a. So it will be a container that has, so it calls t. It has a link to the value of the a. So it shows to a link of a and link object of element to the value of a. And after that, you create a new object 3. You get rid of this link, you create this link. But this link from tuple still exists. It is linked to the previous integer object, not to the name a. Okay?
Okay, thank you. And so for list, the link is made when I create a list which includes the variable a. The link will be created to the variable a and not to object.
No, the same thing. So we have a equal to. We have L list contains a. We have a equal 3. And if we print, it's still 2. So okay. the same thing. The mutability of the list means that for now, L consists of A, but I can say that L0 become now 3. And L will be contain 3. But for the tuple T, we can't say tuple 0, please now be 4. It's an error. We can't change elements inside. But the data model will be the same. So if it will be a list, L, just the same thing.
Okay, thank you. Now I understand.
Okay, any other questions? Okay, guys, thank you very much for your attention. I think I will send your homeworks like on the previous week in the Friday noon. So be careful. Goodbye. Glad to see you.
Thank you. Goodbye.
Thank
Bye.
you. Goodbye.
Thank you.